It's a lovely evening here tonight. And I've got my peppermint tea. I'm wondering if tea is just going to become like a feature, a stream. I'm putting this out at 8 p.m. and this is after I've had a full day at work and made dinner. So I want this to be a relaxing vibe. Tonight, I'm making something a bit different. I'm going to stop with the side table project, pick that up perhaps in the new year, or perhaps sooner. But for tonight, we're not going to do the table project. We're going to design a spice rack. It's a gift, but a gift that I'm going to design and make for someone. But I'm also thinking, two birds with one stone. I can develop this product further and share it open source online. Perhaps also make it available on the website. So let's get right into it. I don't have anything going on the printer right now because the plan for tonight is I'm going to quickly, and I think I can do it quite quickly, mock up a little prototype, get it printed, and test it. I think I can get it printed and tested during this stream, but they're slightly different. And then I've even got this one, which is even bigger. So I'm going to take these sizes and measure them up and basically create a little mock-up model in CAD for the worst case scenario, which I think is probably this shape, this kind of squarish shape, combined with whichever is the tallest, which I think is this one. And that's going to give me a kind of worst case generic spice bottle, which I can use for modeling the prototype. I've been told that the sound's working well. That's good. I'm still pretty new to streaming, so I don't always know whether this is working or not. I've done some sketches to start us off. Apologies for the sort of low quality scan. I don't actually have a proper scanner. I have a A4 scanner. I sketch in A3 typically. And I think from the other day when I held something up to the camera, I realized doing this, holding sheets of paper up to the camera, doesn't work. So I'm bringing it into Rhino and I'm scanning it with my phone. So here's a little kind of really quick sketch of the space that this particular spice rack is going to go to. And some of the kind of considerations that I want to think about. Here's some more ideation. I wanted to bring in, I don't know if you've seen the Frankfurt kitchen, but I'm in love with the Frankfurt kitchen. It was an Austrian designer, and I can't pronounce her name. It's quite a long name. But she basically invented what we would now consider the modern kitchen format. In a modernist kind of, through a modernist lens and through a particularly feminist lens. And so she developed this kitchen, and a lot of the sort of elements of that I love. I think it's an incredible design. I kind of wanted to bring in that. I thought about having little slide out trays with kind of tip bucket mechanisms and stuff. And then I realized Christmas is around the corner and it's going to take way too long to print and assemble all these things. So I needed something a bit more modular and a bit easier to print. So I've come up with a sort of profile which I can print really quickly in a big thick nozzle size. And I'm thinking about attaching the various modules together, either bolting them or come out with some kind of special 3D printed clip, or even just zip ties in a way that might look okay. I don't want to dig deep into the sort of philosophy of it, but a lot of my designs feature really obvious fixing, bolts on the outside or straps around the outside to try and really make it abundantly obvious how this thing's held together. So I've always wanted to do something with zip ties. I haven't really gotten around to it, so I might try and do this. And then if it's just an extruded kind of shape, well, why not spiral that round? Why not make a spice rack where you could put the spice bottle in at the top and it comes round, around, around and slots in at the bottom? I had a few other ideas. So this is what we're going to model. A little mock-up of the bottle, and then get the profile right, quickly print it out, just a short section, and then we can take one of these, test it, and take the design from there. So let's get started. Hopefully that makes sense. I'm going to go in for the front view. I'm going to use my plane and start with line. And this is going to be my height. So let's take the tallest looking one of these, this one, and measure the height. I've got two calipers. I've got a nice one which I keep at work, and I've got this plastic one which does the job but is not the nice one, in case there's any caliper connoisseurs watching. 100 and round it up 106 mil. 106. No. You know, I don't think we need to go for this square shape. I think just a radius is fine. This is, round it up, 42 mil wide diameter. This is 44. Interesting. Yeah, 44. This is 42. Let's just take this extra wide example. That's 54. Okay. Polyline from there. I want to do a bottle that's, this widest one was 4. Oh, it's even wider. Let's just say 4. I don't know. 44. Let's go 44. So I'm going to make this half the width. Down to there. Use the snaps. And I'm going to revolve this. Was there an easier way of modeling that? Yes, of course. I don't think we need to give it that much more detail. I mean, I could start getting into adding all of these, you know, the lid and the split line and whatnot. But that's not the purpose of this right now. This is just to give me little reference point. So I'm going to name it name to assign test pot. And I'm going to show name. Now I've got a little label on there. This these tools at the bottom here are not standard with Rhino. It's a plugin called Peter's Tools because some hero called Peter shared his tools with the community. Now we have them. Now let's go back to the front. Let's take the label. Let's just take all of that. Change layer. Stick it in. Now we're gonna lock reference, so we're not clicking on it. What if we went 2, 3, 4, 5 mil wider? Remember, this is just a test sample. So I'm thinking maybe 15 mil up, maybe even 20 mil. This is going to be a little lip at the front, just to hold it in place, just to stop it from out. I don't want it too high because then it might cover up the labels. And also use more material. 25. Give it an inch, not 2. 20. Give it an inch. Now a good minimum wall thickness for 3D printing is 1.5 minimum. I'm going to give this 2, 3. $2 mil. Kind of doing this intuitively. If I want to include any kind of fixings and things like that, maybe a bit big. Give it 4. Using the grid snaps really helpful for this kind of modeling. Keeping things aligned to the grid and using whole millimeters. Now getting the height right here is really important. No. That's annoying. I clicked off the line. I've had a new thought though, so I draw a rectangle, and I'm gonna copy the outside profile. for a line. Arc. There. So that is giving me, if this rectangle, which represents the spice bottle, were to be tipped out, that's the clearance that it needs to be tipped out. So then we take our spice bottle and the clearance and we move it up by whatever that little lip was going to be. So let's say 25 mil. Suddenly that's looking like it's going to be quite a lot of air above the thing. Let's make it 22 mil by ourselves, a little bit more. So if you imagine now, we've got the lip coming up 22 mil, out by 4. 26. This is the kind of front face lip of the spice rack. The bottle comes up because it needs to clear this, and then I want to give it the clearance to rotate out as well, right? Otherwise we're having to sort of slot it out vertically, and I want it to be convenient. So that it also needs that clearance. Means the minimum distance from the base to that clearance line, 137. So if we just round that up, say 140. From there, 144. Remember our thickness. And we're going to bring that across by the same width. Down by 4. Cross. Down to the bottom and connect. Join. Let's get rid of. Hold up. What? From the bottom to the clearance. 137. Ah, I didn't account for the thickness of the bottom layer as well. I only added on 4 once. So I'm going to take these control points and I'm going to move them up by 4. Now we've got that headroom. Delete my construction lines, delete my fake box. 148. Now there's another issue here. I wanted to keep it in modular units, and I think the units that I was going for was 140. The reason being, this spice rack is a gift from my mum, and in my mum's kitchen there are tiles. And judging by the photos, I had to kind of reverse engineer a kitchen from some photos. The tiles are 140 square. So I'm thinking, if I bring this lip down a little by 8, it's 22. I take 8 off, leave me with 14. It's not very much. 14 mil lip to stop. I mean, it's just enough to hold it in place, isn't it? It doesn't need to be earthquake proof. You know, we're not living on the International Space Station with ice flow. This needs to be enough. So maybe I will bring it down. I bring those control points and those control points and bring it all down by 8. And that's now 140. Let's do our sort of clearances analysis again real quick. Rectangle, move that up to the clearance point, rotate it from there to its most extreme position, and we've still got a few mil clearance, so that's nice. 3 mil clearance. And that was for the taller pot in my example here. The smaller one should still be fine. No. Something that's really important with 3D printing, wherever possible, is to select curve for radius measure. Yeah, it's really important to put round edges because of the way that the 3D printer works. The 3D printer is this print head. Let's call this spice a print head. It's extruding plastic. It's flying around and it's carrying all this mass, all this inertia. So if you're sending it into corners, hard right angle corners, the print head coming up to the corner, just having to come to a full stop, decelerating to a full stop, change direction, and then go another way. Whereas if you add a radius, print head can go around without stopping, like a car going into a corner. Speed up the print, better print quality. So little details like that are just important to think through. Even if it's a small radius, better than nothing. So wherever we can, we're going to do that. Probably could have calculated the proper wider radius on the outside there. Let's not worry about that for now. I'm not going to do these inside ones because I want to maximize the amount of space for the bottles themselves. Oh, that's a point. I shouldn't have this pressed right up against the pot. Should give it some room. So we're going to grab those control points and I'm going to move them by 5 mil. There we go. How wide is this thing? 57. That's okay. That's so far, so good. We're going to extrude that curve. Just do one side for now. I want it to be solid, yes, and let's just give it let's just give it 50 mil. We've now got a little section to be 3D printed. So let's export that. That's the other project. We're working in here. Sneak preview of some other experiments I've been doing. And we're going to call this test print version 0.1. Lovely. This is where we prepare the print in Bamboo. So let me just sync filaments because I just changed the filament. And we're going to bring in the model. Why is it not there? Yes. Ah, because I saved it as the wrong thing. Exports as an STL. Test print. There we go. Now Bamboo is smart enough if I hit auto orient to put it that way. I don't want to play around with the settings. I trust that it's going to be fine. I want it at 0.8 mil nozzle, which is, you know, the really thick gauge nozzle. We could even actually let's just do much bigger layer height, extremely apparent layers, much lower print quality but shorter printer time. Fine, let's just do whatever the standard, the PLA with a 0.8 nozzle. We're just getting a sense of this thing. Slice it up. 40 minutes? Shouldn't be 40 minutes. Quite long. Wall loops. All right, here's what we're going to do. We're going to have 10% infill. Thyroid's fine. And we're going to go back to prepare. And I'm going to scale it in the Z direction by half. No. Non-uniform scale. I'm going to slice that. 21 minutes. Alright, that should take us just to before the end of the stream. So, print plate. Don't need a time lapse. It's being streamed live. Let's go through all the pre-flight checks because I just changed the nozzle. So let's make sure that's running well. Send that to the printer. Lovely. So that's now just going to set itself up. And what we can do is get back to modeling this thing out. So while that's printing in the background, we can start to refine this design. So I just want to test this, fit it up against the pot, see how it feels, see if it looks proportionally right, see if it makes sense. But in the meantime, we can still progress this design. So let's take that curve, copy it. Over there. Right off the bat, I'm thinking I could do rounder corners. So I'm just going to redraft the polyline. Get that profile again. Delete the original. That's our new curve. And actually, yeah, I want rounder corners. I think we can do the whole thing rounded. So radius of 2. Just have totally rounded corners. Although what if I didn't? What if I had something more like this? Remembering that these are going to be stacked. It's a modular system after all. If I have a fillet there and a fillet there, we're going to see this kind of line, this shadow gap. And it might look crisper if they came up kind of, they met at a nice corner. Perhaps. Perhaps that's the way to go. Now there is a kind of formula for calculating what this outer radius. Let's, if I take my arc, put it center. When I look back at my sketches, I had some ideas about how this would all join together. That's it. I was worried that if these were all secured at the front with clips, they you pulled at the top level module and they're all secured only at the front, you've got this kind of pivot point where it could just fall off. So either needed to be secured at the front and the back, or have some kind of dovetail or some kind of means of securing it at the back. Or a magnet. I kind of want to get magnets involved as well. I think if I had some kind of dovetail thing going, that would be very secure, but the problem is look a bit weird on the top layer. Just to have this spiky bit poking up. I'm imagining also that this is backed up against a wall, so I just hatch this in so you can just sort of imagine it being backed up against a wall. I don't really want anything further back than the furthest back face. Perhaps just a little pin. A little pin to go in there. Might just be enough. I think a pin or something like that will work just fine. Great. So given that this is the back, I can round that off to make it easier to print, and these gaps don't really matter. I'm wondering whether it's worth having the gap. Or not. You know, I actually think with the gap, part of what I aim to do is make things sort of intuitive. Intuitive in the sense of like I, as the user looking at the product, see how it was made. So to try and go for these like really tight split lines when it's been 3D printed feels a bit misaligned, and I'd rather make it I don't know, somehow more obvious. I don't know if that's making sense. Makes sense to me in my mind, and that's all that matters. I can see this is a sort of uneven shape, but I'm actually quite happy with that. It gives me a little bit more traction on the bottom. We see how the print's doing. Oh, lovely! Look how thick those layers are. Like over 0.5 mil each time. Oh, and it's just racing. That's brilliant. Fine, okay. So how long do we want to go? The bamboo has a maximum print height of about 200 and something. The height that they advertise the build height. They advertise that it's got a build height of 256 millimeters. But from what I understand, in order to actually get that, you have to do some modifications, and it's a bit trickier. So the sort of real print height is something else. Currently just doing a bit of a quick Google. Yeah, 220, 200. It looks like 200 would be safe. So if I extrude, if I extrude curve to 140, then we've got a sort of square proportioned unit, but that's going to be a lot of fixtures. So what if we had a 1:2 ratio, added 70 on, we had 210. We're going to have problems if we do that. Export, height, delete it. Change the element. Have been found. G code to the path have been found at a layer. Oh, it's conflicting the models. So it's saying, let's just get rid of that one. That would take an hour and 40, hour and 50 to print with the settings that I've got. It might take a little bit longer. The 2-hour print fits in the build volume by the looks of it. I'm not getting any errors. And it's a 1:2 ratio height to length. So that's pretty good. That's pretty okay. Let's stick with that, with those proportions. It looks super simple, and it is super simple, but then we imagine how we're gonna kind of modularize it. Good point there. Let's do this. Okay. All right. Kind of interesting. Basic and interesting. Now, let's add some of those fixing points. I say 3 mil wide. I'm gonna get some zip straps from the cupboard. Right, we're back. These ones that I've got in stock, 4 mil wide, 1.1 mil thick. So 3 mil wide and 6 mil long. We'll definitely do it. Now, I don't necessarily need to round out these edges because the way this is going to be printing, the layers are going to be in this direction. The layers are going to be looking like this. So if I round out these corners, I'm just going to end up with, it's not going to be that tidy. So this way I can actually keep it as these sharp corners. Start at the mirror plane. The midpoint. There we go. There we go. This is time to put my space mouse on. Let's check the print. Looking nearly ready. %90 there. Both sides. What I'm thinking is I might punch it all the way through. And then I can come up with a little part that slides in the end as a sort of gate to stop the spices falling out the end. No, these are crazy long. Doesn't matter. It serves my purpose. Copy that corner. Let's just do more than one bird with one stone. Delete the other variations. We'll copy later. Zoom selected again. Get our bearings right. Boolean difference. Poly surfaces to subtract from. Poly surfaces to subtract with. Look at that, we've got some holes. Again, I can tweak it and correct it later. A little bit more work because I don't have that feature. Sometimes I forget to make copies of things. It's a bit of a hindrance because I need to redo work, but now they're not looking. Print's done. Look at that. Let's test it. So here's the print plate. Get it off. This, what do I think about the proportions of that? Bad, not too obtrusive. For a bit longer. And the layer orientation. How do I feel about being able to see the layers in this orientation? Kind of gives it some height. Sense of height. There's bags of room in that. Even fit this one in. Can't fit the big one in. So I could either increase that a little bit more to get the big one in, or accept that that's not fitting, and maybe even make it a bit narrower. I do want it to be easy to get in and out. Maybe that could be, doesn't need to go in that much. I think I'm going to bring that in just the tiniest amount. Still needs to be a good clearance in there. I still need to be able to maybe get a finger in there because it needs to come out easily. But I have given it an enormous amount of headroom there, so I can bring it right the way up, out, very easily, almost too easily, really. I think what I'll do, here's the things I'm going to do. I'm going to bring this gap in very slightly, just to make it a little bit more snug. But I don't want it to be an interference fit. I do want it to be generous clearance fit. I think I'll keep this height for any variation in the bottles, and so that it is genuinely easy to get in and out, especially since we're going to have, you know, more of these on top. Don't want it to be crashing and making it being difficult. Lots of room. But I can add maybe a really thick chamfer in that corner for a bit of extra strength. You know, bear in mind, this shelf is going to have another row of spices sat on top. Maybe even another row on top of that. So strengthening that corner. Yeah, maybe what I'll do, I'll add the fillets on the inside here, make it a bit easier to print, reduce some of the bending stresses in that corner a little bit, add a big old wedge of a fillet in there. That's going to help strengthen that as it stacks. I've definitely got the room for it. Loads of headroom. I'm going to tighten that clearance up a little bit more. And I think that will do it. That will do nicely. What I was going to get to, let's give you a sneak peek of where I intend to go with the development of this. So here's a nice sort of point to pause at. I'm going to open up what I was experimenting with before. So imagine the same concept, but printing it as a spiral. So you pop the spice in the top there, whee, and it comes all the way down and then connects with the modular rack that's coming out like that. And this was me experimenting with how the sections of it might get printed. If I zoom back over here and I open up Grasshopper, what I can also do, conveniently, since earlier tonight I accidentally saved what I intended to be as an STL as a Rhino file, I can import from the project folder what is this? Ah, because I'm not on Google Drive. Test print. Put that straight in. Now that's much bigger than I was experimenting with earlier. Can you see my... Ah, okay. Pardon me for a moment. There we go. Helix. Okay, so this is where I'm generating the helix from. The reason why I'm doing it in Rhino is because there is a helix function in the reason why I'm generating it in Grasshopper is because when I generate it in Rhino, it does a funny thing. So there's my axis, and that's the width. Now, do you see how if I look at, let's do that again, but with the right number. Turns 3 from there. You look at the black line, the helix that I generated in Rhino, the angle of attack, let's say, in this corner is coming up from the point at an angle. Right, the sort of tangent angle of this curve, not flat, it's not horizontal to the ground. So I want to try and generate a helix where it starts off coming out flat, then bends up to form the helix shape. So it's not actually a true helix what I want. But it's what I need, because if I'm then to extend and join together this with more modular units coming out in a straight line, it needs to be tangent to it properly. It needs to be aligned with it properly. It can't just be coming up at a funny angle. So I have to create a funny helix so that it doesn't come out at a funny angle. So let's increase the radius of that to 100. Let's just say, let's move that to 100. I want that right in the at the start point of that. Move kind of that point. Let's move that to the origin and then move that forward by 100. That's now going to hit that helix at the point where it touches the ground. Fine. Now, what's this? That's my height. Is that my height? I think this is the number of turns, if I'm not mistaken. That's that. 240. Sorry, 280. That line is crashing. I want it to be a whole number. Okay, fine. And then here we're gonna duplicate dupe edge. Oh, I have to go around and select the whole thing. There must be a way. Dupe border. Dupe face border. Look at that. There's always a command for it. That's what I want. And then I'm gonna do no, I need to jump back into Grasshopper. I'm gonna bake this curve. Then I can do a sweep with that as the rail, that as the shape. Run it. Road-like version. That needs to be flipped. And this is kind of what the grand finale piece is going to look like. Which then just attaches nicely onto the modular section. I might need to really think about how it's going to be supported, how it's going to work. Maybe I'll need to add sort of columns in here or something. Yeah, this is kind of the crazy end goal. If I get there in time for Christmas, that'll be fantastic. Otherwise, where we got to today, I'm flicking through all my screens, with this kind of design, extruded out, clipped together to make a modular stackable spice rack, is a really good place to be. Slightly longer stream than usual, but I think I'm going to call it there for this evening. Thank you for watching.